Respected Sir, myself Maria Lepcha and I am doing my graduation from Namche Government College of Sikkim, affiliated under Sikkim University. This presentation is part of my sessional test which carries 25 marks. The topic of my presentation is GAM counter, that is Geiger-Müller counter. Introduction. The Geiger counter is an instrument used for measuring ionizing radiation, used widely in such applications as radiation dosimeter, radiological protection, experimental physics, and the nuclear industry. It detects ionizing such as alpha particles, beta particles, and gamma rays using the ionization effect produced in a Geiger-Müller tube, which gives its name to the instrument. In wide and prominent use, a handheld radiation survey instrument, it is perhaps one of the world's best-known radiation detection instruments. Original detection principle was discovered in 1908, but it was not until the development of the Geiger-Müller tube in 1928 that the Geiger-Müller counter became a practical instrument. Since then it has been very popular due to its robust sensing element and relatively low cost. This is the diagram of GM counter. History. The original detection principle was discovered in 1908, the development of the Geiger-Müller tube in 1928, that the Geiger-Müller counter became a practical instrument. It has been very popular due to its robust sensing element and relatively low cost. It cannot could detect alpha and beta radiation as prior model had done, but also gamma radiation. It could be produced radioactively, and so GM was introduced. Modern version of the Geiger counter used the halogen invented in the 1947 by Cindy H. Lisbon. It suspended the earlier GM tube because of its much longer and lower operation voltage, typically 400 to 900 volt. This is a diagram of old GM counter. Principle. All the nuclear radiation such as alpha, beta and gamma radiation will ionize while passing through a gaseous medium. This ionized property of nuclear radiation is used for the detection. In the GM counter, the central wire acts as an anode and the act as anode cathode. When an ionizing radiation such as alpha, beta, gamma radiation enters the tube, it ionizes some of the gas molecules in tube. From this ionized atom, an electron in its storm come out of atom. The remaining atom is positively charged. Due to the high voltage in tube, it produces electric field. The electrons that comes out of the atom are attracted to positive electrons, and positively charged atoms are attracted to negative electrons. Theory. The common radiation detector make use of electric conductivity of a gas resulting from the ionization produced in it. The gas counter consists of a suitable chamber containing usually and in gas such as argon at atmospheric pressure. A central electrode in the form of a wire and a thin end window. The central electrode is kept at a positive potential anode and the chamber at negative potential cathode. When a potential is applied between the electrode, the gas is ionized. The positively charged heavy ion moves toward the wall the container, the electrons move toward the anode. The ionization current can be measured by suitable electronic circuit or can be digitalized and measured as count per minute. As we increase the applied voltage across the electrode, initially there will be no current till the threshold voltage for ionization is reached. There on the current start increasing slowly at the early stage as the ions have a tendency to recombine till a sufficiently high potential is applied. The negatively charged electron moves swiftly toward the central anode at the heavy positive ion move relatively at a slower speed to the cathode. This does not seriously impair measurement as the applied potential relatively slow. Further increase in the potential show a plateau over a region of about 100 volts. In this region, the output current remains steady as all atoms interacting with a radioactive emission get ionized. This region is known as a saturation current region. The current produced is a direct measure of the rate of production of charged ion. Among all three radiation, alpha, beta and gamma, the alpha particles has a short range as it has large mass and charge. Consequently, this region is most sensitive to alpha particles and the other radiation contribute very little. As the applied potential is quite low, the current produced is small and require good amplification. To eliminate any absorption of radiation by air and window material, the radioactive source is kept inside the chamber itself. Merits of GM counter. Number 1 point. It is very useful for detecting nuclear particles like alpha, beta and charged particles. Number 2 point. It is very sensitive even for production of single ion pair. Number 3 points. Plus height is independent of nature and energy of incident particles or radiation. Demerits of GM counter. Number 1 point. These detectors have low efficiency of counting gamma rays. Number 2 point. These detectors lack information of detected particles. Number 3 point. Detectors cannot detect uncharged particles like neutrons. Conclusion. Geiger-Müller counter are regarded as one of the best radiation detection instruments and is used widely as prominently. Geiger-Müller counter are used in numerous fields and it is regarded as best tool for detection and instrument of ionizing radiation. The mica window of a Geiger-Müller allow passes of alpha, beta and gamma radiation. The radiation ionize the gas inside the tube. Thank you.